Okay, so factor trees are really useful in order to find the prime numbers which make up a whole number, and when multiplied together make the whole number. So we really need to know what prime numbers are first. So what are primes? Primes are numbers which have two factors, one and itself. For example, the number 2 has two factors, 2 and 1. Also, the number 3 is a prime number because it has two factors, 1 and itself, 3. And the number 5 is a prime number because it has two factors, 1 and itself, and the number 7 and the number 11. And I'll just, so to make this clearer, I'll just show what those factors are. We think of factors as numbers which multiply together to make that number. So 2 times 1 makes 2. No other numbers when multiplied together make 2. Same as 3 times 1. 5 times 1 make 5. And 7 times 1 makes 7. And 11 times 1 makes 11. So prime numbers are numbers which have two factors, 1 and itself. So in this case, 11 has the two factors, 1 and 11. So we want to look and stop our factor tree when we reach these numbers here. And there's a really easy way to do our factor trees. Let's look at the number 48. Now, in our number 48, we need to think, okay, what two numbers when multiplied together make 48? In other words, what are two factors when multiplied make 48? It's really easy to pick out the smallest prime number. So the smallest prime number that we have is the number 2, and that's really easy to use because if we look at the number 48, it's an even number, so we know we can divide it by 2. So we can start by going 2, and we know 2 times 24 gives 48, and we make sure that those numbers are attached to the lines that branch out from 48. Now 2 is a prime number, so I'm going to use pink here to highlight it to say that we don't take that number any further. We have found this factor and we don't need to continue we've found this prime factor, so we don't need to continue this branch. However, 24 is a composite number. So I'm going to shade this green because it's a composite number, it's not a prime number. It has many more factors to say that we keep going with this number. We keep factorizing this number. So, two numbers which multiply together to make 24. Obviously, we want to pull out our prime again, so we can bring out 2. Now that's a prime number. We don't need to factorize that further. And 2 times 12 makes 24. And 12 is a composite number, so we leave that there. We know we're going to keep going, and green here signifies to you that you want to keep factorizing and you want to keep finding the factors of those numbers. So looking at 12, we've stopped at 2 because it's a prime number. We want to pull out a prime number again. The easiest one is 2. 2 times 6 makes 12. So we know that 2 is a prime number. So we stop there. However, 6 is a composite number. It's not a prime number. It has more than 2 factors. So we know we need to factorize this one further. In fact, we probably just need to do this one more time because what you'll notice is we know 6 is made up of 2 times 3. And these are both prime numbers, so we can stop there. Now looking at this branch down here, there are no more composite numbers, so we don't need to factorize further. Now, when we have a question like this, draw a factor tree and write a number as a product of its primes. Where we see this language here, write it as a product of its primes. Product means we want to multiply. Okay, that's what product means. And when we want to multiply of its primes, it means we want to use all these numbers here to multiply them together to make and equal our 48. In fact, that's what it's going to be. So 48 equals 2 times 2 times 2 times 2. So we're using the ones from here, 2 here, times 2, which is up here, times 2, which is here, times 2 we've put here, and times 3 on the end. So I'm using all those pink numbers. I'll highlight them again so you can see. I'm using all those prime numbers that we factorized from 48 and multiplying them together. They make 48. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. So that's what it means when we write a number as a product of its primes. Now we've learnt that we can simplify this further, and we've learnt that 2 times 2 times 2 times 2 can be written another way. We can write it as the base number 2, and it's written 4 times, so we write it to the power of 4. And then we just write our times 3 on the end like that. So that would be our answer there. When it says write the number 48 as a product of its primes, that's what we're looking for. You'll need to do a factor tree first. Doesn't matter how you do it, and we'll look at another way of doing it shortly. And then you need to write it like this as a product of its primes. 2 to the power of 4 is 16 times 3 is 48. All right. There are other ways that we can do our factor trees. I think this is the easiest way, always pulling out the 2 first from the numbers. But you might do it a different way, and you might just look at the factors of 48. So you might look at that and go, well, 48 is, okay, 2 times 24. And you might go, whoop, I've got a prime number here, and I've got a 24 here, so I can keep going. My composite number still needs to be factorized until it's primes. So then I might go 24, and instead of doing taking a 2 out, I might go, well, 3 times 8 is 24. And we know that 3 is a prime number, so I can't factorize that further. And 8 is a composite number, so I can factorize that further. And to get 8, I can go 2 times 4. Doesn't matter which branch you write your prime on and which branch you write your composite on, as long as you know which ones stop and which ones keep going. So 4 is a composite number, so it stops, but 2 is a prime number, so we don't keep going. And to get 4, we get 2 times 2. And we know that 2 and 2 are prime numbers. Okay, so this factor tree is quite a bit different to the factor tree you've got over there. And it doesn't matter which way you do it, as long as you pull out the answer that's right at the end. As long as you pull out that this number can be written as a product of its primes, and that will only happen in one way. You'll always get this product of primes here. So we can write 48 as 2, getting this prime number, times 3, times 2, times 2, times 2. And we can see that there are 1, 2, 3, 4 primes, so we can 4 2's. So we can write 2 to the power of 4 times 1 3 there, and you can see that it's still has the same answer, that it doesn't matter which way we go, we can get the same answer there. Okay, of course there are other ways to do it. You might go, I won't do the colours this time, I'm hoping you know what a composite number is and a prime number is, and you can see how we've done that. But 48, we could do it a different way. I could go, well, let's go 12 times 4. And they're both composite numbers, aren't they? They're not primes. They both have more than 2 factors. So I need to continue with both of them. So I'll have to go 2 times 2 here equals 4. And 6 times 2 here equals 12. And 3 times 2 here equals 6. So I've got 3 times 2 times 2 times 2 times 2, which is 2 to the power of 4 times 3. I will actually put the colours in, I think, just to show you where my composite numbers are. Okay, so the green are composite numbers. That means I needed to keep factorising. And my pink are my prime factors, so I just need to stop there. Okay, and the pink ones are what multiplies together. They're my prime numbers. So my answer is going to be 3 times 2 times 2 times 2 times 2. 1, 2, 3, 4, and 3. And it's going to be the same as all the others, just done a different way. 2 to the power of 4 times 3. It's exactly the same. Okay, and that's how we solve for finding or writing a number as, I've lost my little cursor, a product of its primes. Okay, I found my number 48 and I've written it as a product of its primes, which is 2 to the power of 4 times 3. This is how we got our primes. We used a factor tree, and that's our answer.